You know that when we learned about Python, we had an integer type, and those integers could be more or less of an arbitrary size. However, in Java, this is not true. Suppose I do something like this. I'm going to say int n gets 1. Then I'm going to say while n is greater than 0, n plus plus, semicolon. And we'll have to wait a little while, but what happened to n? Whoa! Okay, this is called type overflow. Integers in Java are stored as 2's complement notation. And what happens is when the integer gets larger than the type, it donuts back around to the most negative integer, and you get this effect. But we would still like to have integers of an arbitrary size. Java provides a solution for this. Now let's open our browser here and go to the Java website, and let's type in BigInteger. Okay, if we're writing a program, we'll see that we would need to import java.math.BigInteger. However, JShell automatically imports that. And the way we can check is just do the /import command, and you can see java.math.star. It's pretty lax. It imports everything under the sun, so we don't have to worry about importing items. Now, let's talk about how to make a big integer, because it's not what you'd expect. You might try to do something like this. Huge is equal to new big integer of 2. Wah, 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 wah. What? There's no constructor like this? What am I going to do? Well, let's look in the API guide and see if we can't find anything that might be helpful to us. Let's look at the constructors and see what is there. Okay, we scroll down here and we see all kinds of things about byte arrays. I'm not interested in that. Oh, although you can take a string that contains a huge integer or an integer of any type, and it will convert it into a big integer. You can do it with a base, all right? But let's go down to these methods. And if you scroll all the way down, you're going to find a method called value of. It's right near the bottom. And so I'm going to go and find that method, value of. Where'd it go? Oh, here it is. You'll notice it's labeled static. That means it is a property of the class as a whole, and that you can call it by using the class name. So if I want to promote, now let's take a look over here. It'll take any long and convert it into a big integer. Such a method is called a static factoring method. Let's try making big integer. Huge is equal to big integer dot value of 2. Okay, now we have 2 as a big integer. Well, what can that do for us? Well, here's one thing it can do for us. Watch this. Big integer has a method called pow. And so what I'm going to do is I'm going to say huge dot pow of 1,000, just for kicks and grins. And you will notice that very rapidly, 2 to the 1,000th power is computed. There is no double star operation that does this. You have to call a method called pow to make that happen. Java does not allow operators to be overloaded like Python does. Python does it via the mechanism of hooks, special methods, the double underscore methods, but here you do not have that facility. So to get started, let's do a little arithmetic. So let's make a big integer. A is equal to big integer dot value of, say 4. And now I'm just going to hit my up arrow key and I'm going to make a 5. And I'm going to call this bad boy B. Nope. Crash and burn. What you have to do is A dot add of B. And notice B dot add of A also works. Now, while those produce an identical result, they are actually different. A dot add of B is adding B to A. So A is the this object, and B is the that object being passed in. Whereas in the second case, the roles are reversed. But since addition is commutative, the order in which this occurs is immaterial. So if add is how you add things, subtract should be how you subtract things. And it appears to work. Okay, let's be rabbit-like and multiply. Okay, we can do that. A dot divide. Okay, that's performing integer division. So is that. So the remainder is being discarded. So we have add, subtract, divide, multiply. Let's see if there's anything else in here that's of interest. So let's go back to our big integer and see what other things. Now, there are static constants, 0, 1, 2, and 10. And to make them, you just go like this. You go big integer, because they are static. And 1 spits right out, okay? So that's how you use the static constants. You can see that they are present, all right? Here are all the constructors. The primary constructor that we will use is the one that takes strings, all right? You can also fool with bases, different bases, radices. Hey, that's something you can experiment with and learn about, all right? You'll also notice that this constructor will throw a number format exception if you give it something stupid that's not a valid parsable integer. Okay, so you can get an exception there, and it warns you that it throws one. Okay, so now we can go ahead and let's go ahead and back up to the method summary and start looking at the methods and seeing things that interest us. ABS is absolute value. So I could do something like this, A dot subtract of B. That's a big integer, so I can call ABS method on it and get the absolute value of that difference. All right, so there's your absolute value. Here's add. Okay, I'm not going to deal with that, the and or operations on big integers. You can explore them. Now, here's an important thing. If you want to compare and see which big integer is bigger than which, let's look at compare to. So A dot compare to of B is -1. Now, if you want to know if A is less than B, here's a predicate that will do the job. Okay, so you can stick that in an if statement. If A dot compare to of B is less than 0, that's idiomatically, it's this. Idiomatically, it's A is less than B. Okay, you can think of it that way. So whatever that operation is that's sitting in here, whatever that relational operator is, you can substitute that. And so A dot compare to of B greater than 0 is A greater than B, less than or equal to, etc., right? Not equal to. All those work very nicely. And all you have to do is compare the result of the two to 0, and you can find out what's going on, okay? We have divide, double value. What does double value do? Let's look at it. Double value is let me get rid of this annoying page. Double value converts a big integer to a double. So if it admits that So let's try something on for size here. If I go big integer equals huge, which was 2.pow of 100. Oh. Did I? Oh, there's big integer. Oh, huge. Yes. Oh, it seems to have forgotten. Let's just remake it. Big integer. Huge. Oh, I see what I did wrong. I need to say big integer out is equal to huge dot pow of 100. And out dot double value just turns it into a double. Okay, so that's fairly straightforward. And there are other methods of this ilk. Here's one that converts it into a float. Let's see, does that overflow? I rarely, if ever, use floats. No, float will go up to E38, so float is fine. You could convert that into a float, but I seldom, if ever, use float. Int value turns it into an int, but something could go wrong here. Let's try out.int value and see what happens. Ooh, that's really bad. That's, oh, wait a minute, out.int value. No, huge.int value. No, oh yeah, we said huge.pow. Out.int value gave us a 0. That's kind of awful. You have to be careful because type overflow can cause errors. And we have a prime example of it. We know our integers are 32-bit integers, and we know we can't cram this thing into a 32-bit integer. It's way too big. So you're getting some kind of donut effect there. There's a long value for converting to a long. So it's caveat emptor here. You got to pay attention to how big your big integer is so you don't get in trouble. Max, okay, that's straightforward. It'll compute the bigger of two big integers. Mod pow, this one is very useful in cryptography. All right, here's multiply, negate. Okay, again, there are Boolean operations going on that are bitwise. I'm not going to concern myself with those. But here's pow. Okay, here's remainder. So this is basically your mod operator on big integers. Signum returns 1 if the big integer is positive, -1 if it's negative, 0 if it's 0. Okay, you've got subtract. ToString does the obvious thing. It just converts it into a string. Okay, and here's your value of method. So you have all of basically all the features of Python's extended precision integer arithmetic, but the price you're going to pay is there's a certain amount of verbosity going on in here that you've got to worry about. So that is big integer.